Very good morning, friends. I am Dr. M.H. Chennaiya, and in today's video, we have a numerical problem on a flange coupling which is used to connect two commercial shafts of diameter 50 millimeter. And friends, basically, in all these couplings, you have a formula to find out the power, that is a torque, MT formula. Then there are two formulae to find out the torque transmitted by the key in shear and compression, and a formula to find out the size of the bolts, and another formula to find out the dimensions of the flanges used in the coupling. So friend, basically if you are able to work out number of problems, you need not remember any of these equations and they will all come to you automatically. Friends, let's see what is the question we have for today's video. There is a flange coupling used to connect two commercial shafts. I will tell the meaning of this. Having 50 diameter, there are four bolts of same material as that of the shaft. That is, the shear stress for the shaft is equal to shear stress for the key. They are the same value. And they have also given you the bolt circle diameter. That is the diameter of the circle where these bolts are located. And you should be very careful. See, most of the times, instead of giving the number, they give this number of bolts in terms of a wording. So they don't give you the numerical value. For they are just written FOUR. So you should be very careful. And friend, they are asking us to find out what is the size of the bolts required. So anything on bolts, whether it is a cross-sectional area of the bolt or the standard size of the bolt or the torque transmitted by the bolts, we have only one formula. And in one of our old videos, we already used that formula. So in the first step, is asking us to find out size of bolt. We will take up the part 1. We are interested to find out size of bolts. Friend, to find the size of the bolts, we need to have what is called the torque. And for these bolts, there is a formula. The torque transmitted by the bolts, empty bolt, is given by I pi d1 square by 4 multiplied by tau v multiplied by capital D1 by 2. This equation is available in the machine design data handbook. Friends, here, what are these parameters? So to find out the size, that is pi d1 square by 4, which I represent as AC. AC stands for the core area, and this is tau v, is the shear stress of the material. D1 by 2. D1 is the bolt circle dia, and it has been given as 240. That is diameter by 2. This is the equation we have got. And to find out the size AC, I should know what is I, what is tau b, and what is MT. Friends, remember, in any of these couplings, the torque transmitted by the shaft, the key, the bolts and the flanges is all same. So based on this, since the shaft diameter is known to us, we have a formula which relates the torque MT with that of the shaft dia small d. That is, MT is pi d q by 16 into eta into tau shaft, the shear stress in the shaft. This equation again available in machine design handbook in the chapter of these flange couplings. Friends, here let us substitute the values known. It is pi by 16. Diameter, D is the diameter of the shaft, that has been given as 50 mm, 50 cube, multiplied by eta. is a keyway factor and its value is generally 0.75 to zero point 0.8. So I will take 0.75 and tau s stands for the shear stress for the material of the shaft used in the coupling. And he says he has not given any metric but says it's a commercial shaft. So there is an ASME code, and as per the ASME code, the value of this tau is 40 Newton per mm square. So the value of this tau is for the shaft, it is 40. This is as per the American Society of Mechanical Engineers code, ASME code. You have this value and this you should remember. Friends, you have put this value, we know everything on the right hand side and we get a value as 736310.78 Newton millimeter. This is the value of the torque that has to be transmitted by the coupling. Now friends, we have the value of torque. We can put this value here and we know I, number of volts, etc. We will be able to find out AC. So I am going to substitute this value here. So when you make the substitution, the value of MT is 736310.78 is the torque is equal to I is the number of volts and it is specified in the problem. There are 4 volts used in the coupling and hence this is 4 times. AC is the core area which is to be found out. Then comes tau B. Tau B stands for the shear stress for the material of the bolt and it has been given that the shaft and the bolts are made of same material. So hence this also will have a shear stress value equal to 40 Newton per mm square. 240 by 2 is 120. Friends, we have got all the values and we will be able to find out what is AC. AC is the core area of the bolts. Core area of bolts and this works out to a value equal to 38.35. 38.35, that is millimeters. That is the core area we have got. Friends, when you have the core area, you will be able to find out what is the size of the bolt required. And friends, when you refer to the table in the machine design handbook, there will be a value corresponding to this, that is a slightly higher value. That is, we see the handbook for AC equal to 39.2 is a standard value available in the data handbook MDH. A value equal to this or greater than that, comma, we select M8 into 1, M8 into 1.0 volts. That is, friends, when you have the core area, you will be able to get the standard size of the bolts like M8 into 1.0. So what is this M8 into 1.0? It is a metric screw thread having 8 millimeter nominal diameter and 1 millimeter pitch. So when you have the core area, you will be able to find the standard size of the bolt required, and similarly if you have the standard size of the bolt available, you will be able to get the core area. So friends, this is the answer, that is the size of bolt is M8 into 1.0 is the standard size of the bolt required to make this coupling. Friends, after completing the first part of the question, let's move on to the second part. Is asking us to find out what is the power transmitted. Means using this coupling having shaft diameter 50 mm, what is the power that can be transmitted? Friends, for the power to be transmitted, we have this formula MT of the coupling, whatever it may be, or MT shaft, whatever it is, or MT key, or MT volt, they are all based on the same value, is equal to, in general, 9550, or you can say simply MT. MT in general is 9550 into capital N divided by small n, so many Newton meter. This expression we have got, where the value of this MT already you have calculated as 736310.78 is the value of torque, and this capital N stands for the power transmitted, which is to be found out, power transmitted. So that is to be found out, that's under question mark. And small n is the speed of rotation, or the RPM, is equal to board material used on a board circle law. Determine this using at 200 RPM. Power transmitted at 200 RPM. So we say 200. Friends, let us substitute in this formula. We will get 736310.78 is the torque transmitted, is equal to, what are these? 9550, this is Newton millimeter, we will write down. So into power transmitted divided by RPM. Friends, if you simplify, this works out as power n is equal to 15.42 kilowatts kW. And this is the power that is transmitted by this coupling having 50 millimeter shaft diameter. Friends, I hope the presentation was interesting, and after going through this video completely, if you like the video, do share with all your friends. Thank you, friends. Have a nice day.